Okay, today you're going to go over exponential growth and decay, and I want you to be able to identify if an exponential function represents growth or decay. I also want you to graph an exponential function. So let's start out here with the basic exponential function. We have a base, and then we have an exponent. Now, x is going to be in the exponent. So an exponential function has a variable in the exponent. And we haven't worked with any functions so far this year that have variables in the exponents. So the graph to the right represents an exponential function of 2 to the x. So I just made a little table off to the side here so we can see what's going on. If I have x is 0, I put a 0 in here. So 2 to the 0, anything to the 0 power is 1. So when I graph that, it's 0, 1. If I change the x to a 2, that means the exponent changes to a 2. So it would be 2 squared, or 4. So when we're looking at exponential functions, if this base right here is greater than 1, we say that the exponential function shows growth. If the base is in between 0 and 1, so less than 1 but greater than 0, we say that the graph shows exponential decay. Okay, and that's as easy as that. So when we have a table down here, I put a box around all of the numbers that are being raised to the x power. So you just look at the base. So just this right here, whatever's being raised to the x power. So since this is 3, it's larger than 1, we say that it's growth. This one is 0.5. We don't worry about the 4. We just look at the 0.5, and that's in between 0 and 1. So we say that that one is decay. Here, we don't worry about the negative sign. We just look at this number here, which is 6. That's larger than 1. So we say that it's growth. The other thing that I want you to do today is to graph exponential functions. So we're going to determine first if the function shows growth or decay, and then we're going to graph it. So looking down here, I'm just looking at whatever's being raised to the x power to tell if it's growth or decay. Since that's in between 0 and 1, it's going to be decay. Now, an exponential function that shows growth is going to spike on the right-hand side of the graph. So go ahead and write this into your notes. This is also exponential. This one throws a lot of people off because it looks like you would think it would be decay because it's going down, but you have to look at the location of the spike. This one's spiking at the right, this one's spiking at the right. So that makes it a growth function. This one is just a reflection. Remember, we worked with reflections this year. If you put a negative sign in front of this function here, it's going to reflect. So if it's a decay, it's going to spike on the left. So this one makes sense that it's decay. And again, this is the one that some people have a hard time understanding because it looks like it's making growth, but it's actually decay. So just picture this one being flipped over the x-axis, so as a reflection. So go ahead and write those into your notes. Okay, the next thing that we're going to do is we are going to graph an exponential function. And in order to do that, we have to have some x values. So usually, pretty good bet is if you're given a graph that just has positive values, don't put any negative values in your table. So we're going to start out at 0. That's always a good place to start. We're going to have an x value of 0, 1, 3, 5, 6, and I'm going to add on a 12 just to make it a little bit better graph. Okay, now I'm going to have you pause the video, and I want you to figure out what those values are. Put them into your calculator and see if you come up with the correct answer. Now, one thing you don't want to do, don't multiply these two together and then raise them to the power. Remember, order of operations says we have to do this first, and then we multiply by 10. Okay, so go ahead and turn the video off, and then figure out what your y values are, and then turn it back on again. Okay, hopefully you have these values in your table. If you don't, then just change them. When x is 0, y is going to be 10. When x is 1, we're going to have 7.5. When it's 3, we're going to have 4.2. When it's 5, we're going to have 2.4. When it's 6, we're going to have 1.8. And when it's 12, we're going to have 0.32. So this is a decimal here. All right, let's take all those values and graph them. We have 0, 10. We have 1. Now this is a scale of 2, so be careful. This is 1, and then 7.5. And then we have, well, maybe a little bit down because that's about 7 because we have a scale of 2. So about a little up here. Let me get it in the right spot. So this would be right about 7, so we'll go right in between here. And then we have 3 and 4.2, so just a little bit over here. And then we have 5 and 2.4. And 6 and 1.8. And then we have 12 and 0.32, so that's going to be down there. Okay, now we're just going to connect these, and once it flattens out, we don't want to go over this x-axis here, so we're just going to kind of hug along that x-axis, turn it here, and you can see it's kind of spiking. It's spiking on the left, so it is decay like we said that it was. And when you come and make this flat, I'm going to change this a little bit. We don't want this to curl up like this. We want it to hug right along this without touching, just kind of going right along. Okay, when you make a graph and you're choosing points, you know, I always get asked, do I have enough points? You need to make sure it needs to have a spike, which is this right here, and a flat section. So it's right here. So what I'm saying is you don't want to stop your graph right here. You want to include the spike and the flat section. All right, last thing. You can model growth or decay by a constant percent of increase or decrease. Okay, so here is our equation that we're going to use. It's very basic for increase or decrease. And A of t is the final amount. So that's after you do all your calculations here. That's what you have left over after you do an increase or a decrease. And then we have A, which is your starting amount or your initial amount. We also have R. That is going to be our rate. And then we have our exponent is t, which is going to be our time period, or periods of time. Okay, the base is, because that's what's being raised to the power, is going to be the 1 plus r. That's going to model growth. If it's 1 minus r, it's going to model decay. So instead of writing this twice, once for growth and once for decay, we do plus or minus, and we choose which one we want based on our story problem. Okay. When you have a story problem and it's involving increase or decrease, you want to label everything that you have. So since she's investing $5,000, that's her starting amount. So you can put an A over that. And she has an account that pays 6.25% interest. That is her rate. Now, up next to this rate here, this needs to be written as a decimal. So write as a decimal, which means you're going to divide by 100. Or you can just think of it, oh, here, let me do that. Write it as a decimal, or you're going to divide by 100. So, or you divide by a decimal means, try that one more time. Write as a decimal means you're dividing by 100. Or you can think of it as moving the decimal 2 places here. So this decimal starts here. I'm going to go 1, 2. So my rate would be 0.0625. That's your interest rate. And then we're going to ask how much she will have in her account after 8 years. Well, years would be her time period. So we're going to take all of these values. We're going to plug them into this equation. So I'm going to write that first. A of t equals A. And then 1 plus or minus your rate raised to the t power. Well, because this is interest, we're going to say plus here. So this is plus. And now we can fill in these values. Her starting amount, so A of t is what we're ending up with. That's what we want to know, how much we have after 8 years. Her starting amount is $5,000. And then we do 1 plus her rate, which is 0.0625. We raise that to the t power, which our time is 8. So if we simplify this, that's what you're going to enter into your calculator. So get your calculators out. And we're going to raise this to the 8th power. So don't multiply these together. You have to raise this to the power and then multiply it by 5,000, or you're going to get a very, very different answer. So if we multiply 5,000 times 1.0625 raised to the 8th power, we're going to end up with A of t equals 8,120.85. Now it actually goes further than that, but I'm rounding it off to the nearest cent, so it's 0.85. All right, you try it to do underneath, and I want you to enter the values for x here, -8, -6, 0, 2, 4, and 6. So add this on here. And then you want to decide if it shows growth or decay, and then graph the function.